grade scientists. We're here to do the cooling method experiment. We're going to do the experimental procedure today. And so I'm all ready to go. I've got my safety gloves on. I've got my wait, I don't really need these. Sometimes this is very important when you do a science lab. Today, not so much. We're not using anything that's dangerous. We're just looking at my diet root beer, okay? All right, so we have in our experiment, if you'll remember, the independent variable that we have determined is the cooling method that we're going to use. The dependent variable is how cold my soda gets after 30 minutes in each of those cooling methods. And then the control variables, probably the most important one, is that we use the same type of soda, the same diet root beer in a can. Okay? So now we're going to run the procedure. These 4 cans of soda have been sitting out on the counter for about an hour, so I know that they're at the same starting temperature. So that's one of our control variables. And they are the same type and size, right? Okay, so I have the 4 cooling methods. One is the freezer, one is the refrigerator, which is in the other room. And then this is a bucket just of ice, and I have some more ice to cover up the can so that it's completely submerged in the ice. And in this bucket, I have salt water and ice, and I will put the can all the way in. It'll be submerged completely as well. So this is a very easy procedure. Step 1 is basically put one of them in here, one of them in here with just the ice, and cover it up. Now I'm going to take these. One of them is going to go into the freezer, which is another one of our cooling methods. I'm going to put it there on the top shelf, kind of towards the back. And I'm also going to put this one in the refrigerator, also kind of in the middle in the back. So now we have all 4 of our cooling methods. I have to set my timer. That's another control variable. Set timer for 30 minutes. So I'll see you in 30 minutes. Oh, sorry. I was just taking a coffee break. Sometimes in science, our procedures take a long time, and so it's good to have a nice cup of coffee or a beverage while you're waiting. So a very important part of conducting an experimental procedure is that you're collecting data, and so you need to have a way to organize that data. It needs to be easy to see. So I have created a data table for myself. I have the independent variable here, which is our cooling method. In this column, I have the temperature in degrees Celsius. See, I have the units. That is our dependent variable. And then I have each of the cooling methods listed here. And so when I record their temperature with these thermometers, then I will record that actual temperature here in the data table. And I might use this later on, this data later on, to create like a graph of some kind. So when I analyze the data, I'll make a visual representation that's even easier for me and my audience to understand what the data is telling us. Okay? I also have 4 thermometers that are reading about the same temperature, like 21, 22 degrees Celsius. Just like my diet root beer, I like my room to be cold. Sorry. All right, so now when the timer goes off, we're going to get to measuring our temperatures. Okay, time's up. Now we get to see which cooling method works best to get my diet root beer as cold as possible. So I'm going to take the one here from the salty water bath, salty ice bath. This is the ice one. I got to go get the ones from the refrigerator and the freezer. So here's the one from the freezer. Try not to hold it. Get it warm with my hands. Get the one in the refrigerator. Here we go. So here's our freezer. Here's our refrigerator. Now I'm going to open them. I'm going to open each of them. It's a good thing as a scientist to always organize your workspace so that you don't get confused and you don't get the data mixed up. So there's refrigerator, there's freezer, there's ice, and there's salty ice bath. Now we have to wait a minute or so in order to get our temperatures. We need the thermometers to do their job. And they've already been calibrated, remember, because they're all starting about the same temperature. All right, so now we just get to wait for about a minute and then I'll record the temperatures. All right, so we've waited and given the thermometers a chance to do their job. It's time to record. All right, so the refrigerator is measuring at 13 degrees Celsius. So I'm going to write that down. 13 degrees Celsius. Okay, the freezer is measuring at 7 degrees Celsius. And the ice is 5 degrees Celsius. Wow, I see a pattern. Do you already see a pattern coming through? And then this is the salty water bath, and it is a little under 5 degrees, so we're going to say about 4.5 degrees Celsius. So we've collected our data. Our next step is going to be to analyze this data, look for patterns, figure out what the data is telling us about our independent variables' effect on the dependent variable. And we're going to do that in class, so get ready to write your procedures and do your data analysis. Thanks.